Hello and welcome. My name is Kathleen Ruddy. I'm the CEO of the St. Baldricks Foundation. It's Childhood Cancer Awareness Month, so it's fitting that we're about to talk with a research scientist who has dedicated his life to helping kids with every type of cancer. Dr. Sam Volchenboum is an associate professor of pediatrics and the associate chief research informatics officer for the Division of Biological Sciences at the University of Chicago. He's dean of the master's program, and he designed and launched the University of Chicago Masters in Biomedical Informatics. His clinical specialty is pediatric hematology and oncology, caring for kids with cancer and blood diseases. His research group includes the University of Chicago's Pediatric Cancer Data Commons, a group dedicated to liberating and democratizing international data for pediatric malignancies. He is the director of the Informatics Core for the Clinical and Translational Science Award, and he's director of the University of Chicago Clinical Informatics Fellowship Program. And on top of all that, he's here with us today. Dr. Volchenboum, welcome.
Great. Thanks, Kathy. It's really great to be here, and I'm excited to talk to everybody about the work that we're doing.
Well, great. Well, let's jump right in. We hear a lot about big data, usually in the context of big companies crunching it to sell their products and services. But how is big data used to help researchers fight disease?
Yeah, it's a great question. You know, we talk about big data all the time, and we think about these large sets of genomic data or other types of huge amounts of data. We in pediatric cancer is so rare, thankfully, it's hard to put together big data to do studies. And the kind of work we're doing with the Pediatric Cancer Data Commons is finally allowing us to assemble data sets that are large enough to do these types of big data analyses. And then you can really start to look at the data and start to do better. You can start to use machine learning to do better diagnostics, better ways of figuring out which subtypes of cancer patients have, figure out which treatments work better. Really the numbers of patients we've had available has been the limiting factor in our ability to use big data analytics for pediatric cancer. And we're finally now getting over that hump. So it's a real exciting time now that we're starting to see all these large data sets come together.
You said something really interesting there. You described pediatric cancer as rare, and yet it's so commonly spoken of in the marketplace, if you will. And
Yep.
by the age of 20, I think adults age 20 or more, 1 in 285 of them are childhood cancer survivors. So it doesn't seem rare, but I think you mean rare in terms of medicine and disease and who the patients are, right?
Yeah, I mean, it's only, if you look at the numbers of new cancer diagnoses in the US, it's only about 1% of the amount of all cancer. So there'll be 1.6 million cases of new cancer in the US this year, and only about 15,000 cases of pediatric cancer. So obviously, thankfully, very rare. That just makes it harder to study. But to your point, pediatric cancer has become so survivable in the US that we now have this incredible cohort of survivors. And now we have this new problem of trying to make sure that we have all the data we need to take care of these kids as they go into adulthood, and that we have their information available to them when they need it. So that's an entirely separate issue that we're starting to tackle with PCDC as well.
So you mentioned that cancer is becoming more survivable in kids, and yet it's still the #1 disease killer of children in high-income countries like the US. So talk to us a little more about why sharing data between researchers and between research institutions is so critical to making progress.
Yeah, I'm really glad that you brought that up, because some people look at pediatric cancer as one of the great medical success stories. And it's true, in 1960, if you had leukemia, there was 0 chance of survival. And now that same leukemia is cured in 95% of kids. But we have so many children that have metastatic solid tumors, that have aggressive subtypes of leukemia, that have relapsed or refractory disease, that we still have such a long way to go with these tumors, brain tumors especially, where we have so much research left to do. And if you only have at your institution, say, 20 kids to study, you can't do any meaningful research on that. If you combine the data from 5 institutions, you might have 100 children with a rare subtype. Again, very difficult to do. In our data commons for neuroblastoma, which is a disease that occurs maybe 500-600 times a year in the US, we have 31,000 kids in there now. It's the largest collection anyone could ever have imagined of neuroblastoma patients. And that allows you it's transformational in the kind of research you can do to start to learn about better ways to diagnose, treat, and to follow these kids.
That's very interesting, and it's incredible to hear about the progress that you're making possible. I think it's interesting. I was thinking about something you said. We tend to talk about pediatric cancer as if it's one disease, but it's really so many diseases and many, many subtypes that all behave differently in each child that has them. So I think it helps us understand why you need so much data to figure out what's going to work best in each child. So as a big data scientist working in pediatric cancer, what are your greatest challenges?
Well, you bring up a really great point, Kathy, about the individuality of the disease and the treatment, because we're just entering this new era of medicine where we can really personalize not only the diagnosis of the tumor through genomic testing, but actually personalize the treatment and understand through germline testing in each kid, which drugs are going to be the most effective or which drugs might have greater side effects. So it's a real incredible time now to be connecting these data sets to provide researchers and clinicians with more information about the best drugs for any particular tumor at the right time. The challenges we face are really challenges around data integration. You would think that the biggest challenge we face is getting people just to share data. That's actually been transformational over the past few years, that people want to start sharing data. But the biggest problem is just that historically people don't collect data in ways that are easily shareable. You take two hospitals that are across the street from each other, and I can guarantee you that one hospital is collecting data in a way that makes it hard to share with the other hospital. So what our group is dedicated to doing, and what St. Baldricks has been so fundamental in supporting, are building these ways to create ways for people to combine and share their data together. That's never been done effectively at the scale that we're doing it, and we're finally now seeing the combined benefits of creating these better ways to share data.
I can appreciate that. I once heard a researcher say that there were issues, or maybe bringing an example to what you were saying, is that one doctor might say the patient has a tumor in their head, another might say it's on their face, another might say it's in their cheek, and yet all of those things can be true. And yet it makes it very difficult for you as a scientist to figure out what each researcher is really referring to.
It's incredibly challenging because you want to combine those data sets in a way that lets you study them. And so we actually sit there and we do this, somewhat painful and definitely tedious work of going line by line and saying, all right, you've been calling this cheek for the last 10 years. Tell you what, we're going to all call this face from now on. And that seems like a trivial example, but those are the kinds of on the ground grassroots work that we need to do. So when we put together a team to work on, say, a rhabdomyosarcoma dictionary, we get together folks from the US, from Europe, from Japan, from wherever we can find experts, and we go through the work of line by line coming to an agreement. And then you can go back and take the old data and try to harmonize it into that standard. That's a fair amount of work. But my dream is that going forward, people will use that standard to collect new data so that you don't have to go through all these all these contortions to get the data into a way that's shareable.
St. Baldrick's has been a proud and early supporter of the Pediatric Cancer Data Commons. As its founder and director, what has this funding meant to you and your team?
You and I have had these talks, Kathy. I mean, it's incredible what has happened. So when St. Baldrick's first got involved with the Cancer Data Commons, basically all we had was a spreadsheet full of neuroblastoma data. That was it. We had an Excel sheet. And with the funding from St. Baldrick's, we've been able to launch a dozen consortia across many pediatric cancers. We've been able to build these dictionaries that now are shareable and available to anyone. But more importantly, it's been the seed that has now led to incredible amounts of other funding that we've gotten, not only from groups like Leukemia and Lymphoma Society and Raleigh Foundation and others, but now we have funding from the NCI, the National Cancer Institute, the NIH, all of that has been snowballed from the funding that St. Baldrick's provided and the investment. And let's face it, the risk that you guys took in funding a small operation like we started with. We're 20 people now and we're growing every day. And it's just a real exciting time to be doing this work. And it all can be traced through a thread back to the initial investment made by St. Baldrick's.
Well, that gives me goosebumps to hear. I want to hear more about that. I think it's phenomenal. And I want to take a moment to thank all the volunteers and donors who made that possible. To our audience, if you're just joining us, we're speaking with Dr. Sam Volchenboum, who wears many hats at the University of Chicago, among them founder and director of the Pediatric Cancer Data Commons. So Sam, there are many data repositories in medicine. What makes the Pediatric Cancer Data Commons different?
Yeah, and I get asked a lot about different sources of data that are out there. And I think it's great that people are collecting data and they're trying to share data. We have real concerted efforts like the Gabriella Miller Kids First initiative. There's St. Jude Cloud. There's a Treehouse initiative. There's so many groups that are collecting different types of data on pediatric cancer. And one of the things that sets our group apart is that we put an incredible investment in the standards for the data. So a lot of groups will try to take data from many sources, and then they will spend a lot of time looking at those data and trying to push them together and aggregate them in a way that makes sense. We take a different approach. We go to the researchers themselves, the doctors themselves, and say, listen, let's come up with a standard that we can agree on. Let's all get the data into that standard, and only then will we take the data in. We'll spend a year or more working on a dictionary before we take any data into the commons. Now that's really put us in an interesting position now because we have a reputation for being very, very focused on standards. So groups are coming to us, not just pediatric cancer, we're getting adult cancers, we're getting non-cancer diseases coming to us now saying, hey, can you do that same thing for us that you did for pediatric cancer? And so it's a real exciting place for us to be because we've taken this data, we call it a data first approach, where we put the focus on the standards, because ultimately that's what's going to lead down that's what's going to really help people down the line collect better data, is teaching them how to use standards, how to collect better data.
That is incredible. I love it because it's more proof that phenomenal things in medicine start in pediatric cancer out of necessity, out of the need to innovate to help overcome these dreadful diseases. So since there are other repositories of data, as you mentioned, how do you ensure that there's tight integration between these data stores, and what other types of data can be linked?
Yeah, so one of the initial motivations for building the PCDC in the first place was that people were depositing these large amounts of genomic data, all of the genomic testing on tumors, but with very little clinical data. So you'd have a researcher that would submit a whole bunch of genomic data, and then you might have an age and a diagnosis, but that's it. And so we knew that we could take the rich clinical data that we could collect and connect it to those genomic data through a common identifier. And now we've done that. So for many patients that are in the genomic data commons that have full sequencing data and have a lot of genomic data collected, we can connect those data to the very rich clinical data that we have through a common identifier. And so now you have a really useful data set for researchers, where you not only have the diagnostic information, but you have the outcome information, because we get information from the Children's Oncology Group on how these kids have done. So that makes that genomic data even more interesting. Plus, we also link to the biospecimen data that's in the biospecimen repository that the Children's Oncology Group runs. So you can do a cohort search in our tool, and it'll say, hey, for these neuroblastoma patients, here's how many have tumor tissue in the tumor bank, and here's how you go, and then you can go request those tumor samples. We're working with the NCI now and some other groups, like I mentioned, the Gabriella Miller Kids First group, and some others on how can we do better to connect all of our data together. And to do that, we are working on common identifiers to connect many different data sources. So in many ways, to your point, the world of data is getting smaller as we start to collect these data sources.
So it's incredible to hear and encouraging to hear about all that collaboration that's going on. One might think, though, especially if they were new to this conversation, that we might be replicating efforts by having so many different data projects and repositories. Should there be a place where all of the data lives? And isn't that even feasible and practical?
Yeah, I think there's always going to have to be some degree of federation of data in various places. I think where I like to think about centralization is in terms of any particular type of data, like clinical data. So like we're very good in our group at centralizing the clinical data, but that doesn't mean that other groups aren't going to have clinical data. I think where the danger is when you have replicated data sets and you don't have a gold standard. So if somebody wants to have a set of clinical data, we can mirror that data, or we can have that metadata for searching, but we don't want to duplicate and replicate that data. So we're very conscious of the point that you brought up. We don't want to reinvent anything. If somebody's built a better tool out there for something, let's use that tool. If somebody has a better set of clinical data for a particular tumor, that's great. We can help them by centralizing it, or we can link to their data sets. I totally agree that we shouldn't be replicating efforts, and it's something that we're very conscious and careful about.
So what kind of progress has the Data Commons enabled that wasn't possible before?
Yeah, so if you look on our website, there's over 50 papers now that have been published off of Data Commons data. And one of the common themes that I see are being able to understand rare subtypes of disease better. So you could imagine that if you have, say, 500 neuroblastoma patients, many of them will have the most common type of neuroblastoma, and there'll be a few with a very rare subtype. But if all of a sudden you have 20,000 neuroblastoma patients, you'll have a lot more kids with those rare subtypes, and you can see the outcomes, and you can do better diagnosis, better stratification of risk for those patients. That's one of the things that's being made possible. The other thing, kinds of things we're seeing are people building new data sets that were never imagined before. So I mentioned linking the clinical and the genomic data together. We just had a project where somebody linked clinical and genomic and imaging data together, like CT scans. Nobody had ever thought that we could do something like that, but because the way the PCDC is set up, we were able to link those data sets together, and people were able to do a new kind of study. So that's my hope, is as we grow, we'll be able to do new types of research. Something else I forgot to mention is my goal is that people will come in and get out of these silos. So if you're if you're a researcher, you could come in and say, show me all the tumors that have one particular kind of mutation. Instead of doing it in each disease silo, you'll be able to look across many different types of cancer at once. That's another type of research that we're enabling now. So all sorts of new exciting work. We're at about 35,000 kids in the Commons. We hope to get to 100,000 by the end of next year. And I think you're going to see an explosion of new types of research that people are able to do.
That's incredible. You just outlined a number of very ambitious projects that really were not possible just a few years ago. It's incredible to see how fast you've moved. How are you going to sustain your efforts?
Yeah, it's a great question. I mean, we've been so fortunate to have such sustained, generous funding from St. Baldricks and from some other foundations, like I mentioned. We're starting to do more work with the National Cancer Institute and helping them in their efforts to harmonize data. But I think long term, there's going to have to be some investment by the research community in keeping efforts like this going. And we may find ourselves, wanting to work with, say, pharmaceutical companies and other groups that have an interest in doing development of pediatric drugs for pediatric cancer that may have an interest in working with us as well. All of this goes back to the very strict and rigorous governance we have in place. Everyone knows where the data came from. There's a very high level of control on who can use the data. But we have to keep our minds open as to various ways that we can help sustain this data commons. Once we do the hard work of getting the data in, we want to be able to add more data. We want to be able to change. We want to be able to upgrade. And we want to make sure that we can keep going. I'll say one more thing is that we're a standards first group. So we've built everything in a way such that, if another group came along or another company came along and everyone decided the commons should be over here instead of here, it would be very easy to move it somewhere because we built it in a way that's highly compliant with standards. It's not a one-off by any means, and so this could be moved somewhere else if we needed it to be, which I think is an important marker of sustainability. It doesn't rely on me. It doesn't rely on university. It can be a self-living commons that could live anywhere.
That's incredible to hear. Well, your progress, all your work is so impressive. we really value your vision and leadership and the dedication that you and your team have made and exhibited thus far. And we're very glad you came to us years ago to help you get this into a motion. And I hope you'll allow us to check in with you down the road to hear how things are evolving.
Yeah, I would love to chat again. And I'll just remind you, St. Baldrick supported me as a young investigator 15 years ago, which is incredible. And I can truthfully say that even without that funding as a young investigator, I probably never would have been able to keep my work going and get to the point where I could even start the Data Commons. So I owe so much to St. Baldrick's, and I'm so thankful. And my whole team is just so grateful for the time and effort that you guys have put in to help us. So thank you.
You're very welcome, and that's lovely to hear. And that is proof that every grant matters, and you need to measure it forever, because once someone is into the field, they continue to. It's a ripple effect. It just keeps growing and growing and growing. So thank you for making sure it does. To our audience, be sure to join us again on Friday, October 14th at 1 Eastern, 10 a.m. Pacific, as we speak with Christina Iptoma, a mom hard at work on new approaches in the fight to cure osteosarcoma. Until then, thank you for remembering kids this Childhood Cancer Awareness Month, and for remembering research is hope. Learn how you can support research by visiting stbaldricks.org.